Hello all, this is Anita. Welcome to the machine learning video lecture series. In this video, we will understand very important technique called entropy and Gini impurity while constructing the decision tree. So let's get started. So as we know that decision tree basically means we will be creating or constructing this kind of tree based on the attribute, and finally we will be getting the leaf node or the final classes. So consider we are having the data set containing some feature as F1, F2, F3, and we want to construct the decision tree. So the first step is to select the right attribute for building the decision tree. So which is the first feature I should select as a root node. So for that the entropy technique is helpful. So what is the basic approach to select the right attribute for splitting purpose? So if I'll be selecting in a right way, I'll be getting the leaf node very quickly. Otherwise, splitting of tree will go much depth and it will take the much time. So that's why choosing the right attribute is very important. Now understand the definition of the entropy. So entropy is a matrix to measure the impurity or uncertainty present in the data set or in an attribute. In another way, we can say that it is a degree of randomness in the data. So here you can see this data is the more homogeneous data or pure data. So that's why it is giving the low entropy value. And this data is a heterogeneous data. So it is giving the high entropy. So in decision tree, the goal is to decrease the entropy of the data set by creating the more pure subset of the data. Decision tree models can use the entropy to determine the best split to make the informed decision and build the accurate predictive models. So the formula of the entropy is h of x is equal to minus p of I into log p of I to the base 2 plus q of I into log q of I to the base 2. So now let us understand one by one. So what is h of x? So this h of x is nothing but the entropy. Now here what is x? So x is a collection of the training sample. So here what is P of I? So P of I is nothing but the probability of the success of the event or the probability of the positive classes, and Q of I is nothing but the probability of the negative classes or the probability of the failure of the event. So here you can see the value of the entropy is ranges between 0 to 1. As the node is pure or the data set is pure, so that time we will be getting entropy value as a 0. And here if there is a collection is there, so we are getting the entropy as a 1 because it is an impure split. Now we will understand how to calculate the entropy values with the help of formula. So here you can see, consider this is my data set containing F1, C1, C2 features, and for F1 we will be having 6 yes and 3 no values. For C1 3 yes and 3 no values are there, and for C2 3 yes and 0 no values are there. As we have already seen in the previous lecture that if we are getting either all positive or all negative, so that time we are saying it is a pure split. So here you can see that this C2 is the pure split because here we are getting the all positive values, and if we calculate the entropy of this pure split, so we will be getting the 0 value. And here at C1 we are having the 50-50% positive and negative, so that means here we are getting the entropy value as a 1 because it is a impure split. So we will be checking mathematically how we will be getting the entropy value. So this is the formula of the entropy. H of x is equal to minus p plus log p plus to the base 2 minus p minus log p minus to the base 2. Now here we will be calculating the entropy of this C1 and C2. So first we will be calculating for the C2. So entropy of C2 is equal to minus probability of plus. So here 3 is there divided by the addition of these two, 3 plus 0, that's why 3. So minus 3 by 3 log 3 by 3 to the base 2 minus here probability of the negative classes. So here negative is 0. So 0 divided by 3 log 0 divided by 3 to the base 2. And after calculating this, we will be getting the 0 value. That means it is a pure split. Similarly, we are calculating the entropy of the C1. So here you can see 50-50%. So 1 by 2 is the value. So here you can see minus 3 divided by 6 log 3 by 6 to the base 2 minus 3 by 6 log 3 by 6 to the base 2, and we will be getting the value as a 1. So this is impure split. Now we will be seeing this with the help of the entropy graph. So you can see on y-axis we will be having the entropy values, and on x-axis we will be having the probability of the plus and probability of the minus. So here in this C1 case we will be having 50-50% probability, that means 0.5. So that time we will be getting the entropy as a 1. It is an impure split, and if we are having the probability as a 1, you can see here in this case we will be getting the entropy as a 0. So now we will understand the Gini impurity concept. So again, it measures the impurity of the node, and the formula of the Gini impurity is Gini is equal to 1 minus summation of I is equal to 1 to n probability square. So here we can continue with the similar example as this one. So here we will be calculating the Gini impurity of the C1 and Gini impurity of the C2. Only we are substituting the values into the formula. So here the formula is 1 minus summation of I equal to 1 to n probability square. So here after rewriting this formula, we will be getting the formula like this. So 1 minus probability of plus square plus probability of minus square. So here you can see 1 minus. So probability of positive is 1 by 2 and probability of negative is 1 by 2. So that's why we are getting 0.5 as the maximum value for the C1. And similarly, we will be calculating the Gini impurity of the C2. So that time we will be getting the 0 value over here. So this is the minimum value. Now we can see here if the entropy, the probability of plus and probability of minus is on the x-axis, and that the Gini impurity is on the y-axis. So when we are having the impure split, so that time we are getting the Gini impurity value as the maximum one, and if it is the 1, so that time we are getting the Gini impurity value as a 0. So from this we can say that the range of the Gini impurity can have is between the 0 to 0.5, and lesser the Gini impurity, the better the split is. And Gini impurity of 0 denote it is a pure node, and 0.5 denote it is a impure node. Now take a pause here and tell me what to use, Gini impurity or the entropy, and after done resume the video. So here we will be using the Gini impurity if the data set is huge, and we will be using entropy if our data set is small. So why this? So here for the big data set we will be using Gini impurity because the formula of the Gini impurity is very simple, and computationally it is easier or less time consuming. And for entropy we will be using the log in the formula, or we will be calculating the log values, so it requires the time. Thank you.